So now we'll start with the chapter of electricity. So here is a wire. This is a wire. And wire is made up of matter. All matter have atoms, and in the atoms we have the electrons. So here are the electrons present in the wire. But these electrons, they are able to move in all directions. Some are held tightly to the nucleus, some are free, and they move in all directions. Now again here, these are the electrons. Now what would happen if this end of the wire was made positive while this end of the wire was made negative? We know the electrons carry a charge, and the charge on the electrons are always negative. Since this end is positive, you would expect all the electrons to rush towards the positive end. So have you seen what has happened now? In the earlier case, the electrons were moving in all directions. Now, after you have made this end positive and the other end negative, the electrons begin to flow. So by applying this by making one end positive, one end negative, now the electrons begin to flow. The next question comes is, how do we make one end positive and the other end negative of a wire? All we need to do is connect this end to a battery, that is a positive of the battery, and connect this to the negative. This is the negative. Since this is the positive of the battery, this end also becomes positively charged, and since this is the negative of the battery, this end becomes negative. And we always introduce a switch in between here, and that's because we need to put it, we need to turn it on and off. So here we have a switch which we turn on and off. So here what you expect, all the electrons to move in an ordered flow in all one direction. Thus in this wire, we have current flowing. Let's summarize what we learned. In the first case, we had just an ordinary wire which was not connected to any battery. It was just an ordinary wire, and it had electrons, and these electrons moved in all directions. But then to this wire, you made one end of the wire positive here, and you made the other end of the wire negative. And because the electrons were negatively charged, they all begin to rush towards the positive potential. And hence, a current was now established in the wire. This was the current established in the wire. And how did we make this one end positive and one end negative? All we did is connected the wire to a battery or to a cell, which made one end, this end it made positive, and it made this end negative, and a current was established. Now note one very important point. When the current is flowing, we have electrons flowing. And in which direction do they flow? They flow from the negative to the positive. This is a very important point which we'll come back to it later. So we can define current as the flow of electrons. An ordered flow of electrons is called current. And to establish a current in a wire, we require the cell or our battery. Now here we have two wires. We have wire 1 and here's wire 2. In wire 1, there are a large number of electrons flowing. Very many electrons are flowing to this wire. A lot of electrons are flowing to this wire. However, in wire 2, there are just a handful of electrons flowing in this wire. So if I ask you the question, in which wire there is larger or stronger current? And you would say current in 1 is greater than current in 2. So if current in 1 is greater, why is current in 1 greater? Because the number of electrons flowing there are much larger in number, while in wire 2 the number of electrons flowing are less. So current in 1 is greater than current in 2. So we say that the current depends on number of electrons flowing. So now we can write current equal to charge, that is electrons in this case, over time, number of electrons flowing. So here we have current is charge over time. Now current is usually denoted by I, and charge is denoted by Q, and time is denoted by T. We go back here, so we have current I equal to Q over T. Now we learned that current was equal to charge over time. And when we put the symbols, we said it was I equal to Q over T. Now this I, current, is always measured in amperes. Q, the charge, in coulombs, that's the unit. And we know T is in seconds. Now we'll define what you mean by 1 ampere. How do we define 1 ampere? We know I equal to Q over T. If I was 1 coulomb and time was equal to 1 second, our current I would be 1 ampere. So let's define 1 ampere. When 1 coulomb of charge flows for 1 second, the current is said to be 1 ampere. That is 1 coulomb, here 1 coulomb, flowing for 1 second. Then the current is said to be 1 ampere.